when I was taking courses, I wanted to take courses that overlapped with beekeeping. It's hard to do sometimes when you study machine design and things. But one of the courses I got to take was fluid dynamics. Fluid dynamics were extremely hard for me. They were the class was ridiculously mathy. It really was. But we had one main project, and so the project that I did was the simplest project that could ever be possible. It was flow air over a box and look at what happens. That was my topic. But it was extremely well motivated, and there were a lot of really cool things. So this is air flowing over a beehive, simulated. You can see how the air sort of disconnects, kind of goes around, and sort of cycles back. And there were two things that I learned from this that were very, very interesting and are relevant for also Wisconsin beekeepers. So I'm going to zoom in and then we'll jump forward.
Like an overview of it, or is this like a head-on side?
This is like a cut, so air is blowing 1 meter per second towards the front of a hive. I've chopped it down the center. The arrows represent the direction of flow, and the colors represent the velocity in this case. I should just got that.
Are you looking at from the side in elevation?
Yes, so this is like,
That's what she went
I'm facing my hive and I've cut it down the center, and this is a 2D projection. Yeah. One of the very cool things you can look at though is the pressure. Pressure is very easy it's always calculated in fluid flow. And so one of the cool things is when you have air incident on the front of a beehive, you end up having high pressure, which is shown in red on the front face, and you have very low pressure on the back face. Now, if you look at the magnitude of what that is, which I probably could have done by first order calcs, because it's a very simple conservation of energy, that you have air moving with a velocity that has kinetic energy, and it goes and gets converted into pressure and stored in that kind of energy. But one of the cool things that comes out of this is you can say a lot about how air flows through a hive based on how the air flows around a hive. And so here's why. How many of you have upper entrances on your beehives? Almost everybody. Okay, great. So what I learned from this is that if you have an upper entrance that's in the front of your hive, the internal flows that are going to happen are going to be due to buoyancy. And the reason why is because you have the same pressure, or same gauge pressure, at the bottom of your bottom entrance as your top entrance. However, if you have your top entrance on the back of your hive, then you're going to be susceptible to all kinds of wind gusts. And the wind gusts are going to be what dominate what happens in the inside, like the internal flows of your beehive. So in cold climates especially, which also happens in India in different regions, you want to make sure that you have your top entrance facing the front of your hive. And that way it's going to occur due to buoyancy and not due to wind gusts. And that's something, so this winter, put your front entrance, or your top entrance on the front. Yes?
You're saying towards a prevailing wind.
No. And the reason, it's a good question. The reason why is because you have the reverse if the wind comes in the other direction. So if the wind's coming this direction, the air is going to flow. If you have a back entrance, it's going to flow up and out. If you have wind in the opposite direction, then you'd have air that would flow down and through. So regardless of the orientation of the wind, and there's a lot of other pictures of like diagonal flow and horizontal flow, in general, it's going to be best to have your front entrance or your top entrance in the front.
It means top entrance on the same side as your bottom.
Yes, which is also in the front, but yes. Yes, I see two hands, yes.
So if you're going to ventilate just by lifting the lid slightly,
Yep.
you should lift the lid at the front of the hive rather than the back.
Yes,
of the
if
hive.
you're trying to make it so that wind gusts don't affect the hive a lot. There's some cases where you would want like lots of extra airflow, but in general you want it powered by buoyancy and by the bees themselves. So I'm going to talk about the second thing I learned from fluid dynamics. This was when I was in India, and I was noticing that a lot of the hives were painted very interesting bright colors. There's nothing wrong with bright colors, but they're not white. And white absorbs the least amount of sunlight in general. And you have bee hives that are out in the sun. I was very worried about the bees because they have to thermoregulate themselves and do extra work to keep the hive cool. And I said, well, why are the hives painted these colors? And I got different answers, so I can't say for certain. One of the answers that was very interesting was some of the beekeepers said, well, if one level of government subsidizes our hives, they say we have to paint it this color. If another level of government says they're going to subsidize the hive, they got to paint another color. And so they had 5 different standardized colors for the different levels of government. Another theory is that the beekeeper said, I want my hives this color, and so that's what they got. But the problem is it's not white. And so you have beehives that are getting extra sunlight than what they actually need. So one of the cool things was that I looked at how heat gets wicked away from the hive surface. It's very simple. It's again air flowing over a box. But on this left, I have not a painted beehive, but a diagram, a fluid dynamics diagram, where the color represents how easy it is for heat to get wicked away from a hive surface. Where it's red, and green, which is on the edges and the corners, heat gets wicked away very, very fast. On the hive faces, the heat doesn't get wicked away as fast. And so what it means, very interestingly, is that you can paint the edges and the corners of your hives any color you want. It's not going to affect the thermodynamics of what's going on. But you should paint the hive faces and the roof, you should paint that white. This does not mean that you have to paint it this way. An easier and a better way that I ended up recommending to beekeepers was paint your whole hive white, and then you can paint that front strip any color you want. You can paint it black. It doesn't matter. You can paint it any color, but paint the rest of your beehive white. And so that way, ideally, levels of government can say, I want it pink or blue or green, whatever color you want, but the rest of the hive will stay cool because it's painted white. Does that make sense? Okay. All right. So now I'm going to try, I have a thesis chapter on this, but it's a little complicated. I'm going to show a graph of sort of hive fluid dynamics. It's theoretical. It's not like I did an experiment for this, but I'm hoping it conveys why keeping hives cool is so important. So bees, they have 4 main ways that they can affect the ventilation of hives. They can either evaporate water, more or less water, so that sometimes they forage water, sometimes they're fanning honey or nectar to get it, and that sort of evaporates water. When you evaporate water, things cool down. Another thing is generating more heat, so that can be bees vibrating in place. That can be on hot days, your bees will leave the hive and you have less heat generation inside your hive. You can exchange air with the outside, so that can be bees that are fanning at the entrance, trying to blow more air through the hive. That acts as like a heat exchanger. And then you have heat through the surfaces, which is, again, where you have sunlight, it's beating down on your hive surface. The hive surface is hot, and that's conducting heat into your hive. Unfortunately, I can show using theory that bees can only cool their hives so much. So if it gets extremely hot, the bees can't cool their hives, and this is important because bee brood has to stay cool enough for them to develop correctly. There's a lot of research that has gone into that. And so I wanted to sort of give a motivation for why you really want to keep hives cool enough in hot areas and do everything you can to keep them cooler. So this is a graph. It's a level graph. It's called a psychometric chart. And it's kind of like what a weatherman might use. I'll talk about the axes first. So on the bottom, we have temperature in Celsius. Sorry, that's probably not very helpful for you guys. But we're like 30, does anybody want to convert from Celsius to Fahrenheit?
96 degrees.
Perfect. All right, so 34-ish is probably in the upper 90s in Fahrenheit. So we have temperature along the bottom. And then along the top, we have what is called specific humidity, which is the grams of water per sort of, I think, unit volume, or in this case, it's per unit mass of air. And then these red lines that sort of curve up are the relative humidity, okay? And you notice that they're curved. You can only add so much water to air before it's saturated, and that's why you can't go above 100% humidity. Now, there's 4 different arrows that I have here that correspond to the 4 mechanisms where bees can cool or heat up their hives. One of the methods is, let's say this point right here is the inside of your hive. This is sort of the equilibrium operating conditions inside your hive. Now the bees can do 4 things. The first thing they can do is they can vibrate in place. If they vibrate in place, they add heat to the hive, and that can be represented by an arrow to the right. They can also evaporate water. If you evaporate water, you move up diagonally to the left, so you're cooling the hive, but you're also adding water. If there's a hive surface temperature that's different, you're going to conduct heat. So in this case, the hive surface is cooler than the inside of the hive, so that's an arrow to the left. And then you can exchange air with the outside, and that's represented by, this is the outside conditions, and so I have an arrow going down to the left. You can imagine these as forces. They have to balance to have equilibrium within a hive, and so you have different relative amounts of one to the other to be able to keep internal hive conditions stable. That was a lot of jargon. But what is important, and you can actually see this thankfully on this presentation, this region right here that's sort of darker is sort of the area where bees could keep the inside of their hives. That they could either keep exchanging air with the outside to sort of pull the internal conditions more towards whatever the outside temperature is, or they could add a lot of heat by vibrating in place, move off to the right, they can evaporate and go this way. So this is lovely conditions. They're staying at a little over 60% relative humidity. They're about 34 C. They're happy bees. This is a great condition. On the other hand, if it's a warmer day, then they have they have to work harder, and it's harder for them to keep the same conditions. So in this case, the air outside is hotter than what the bees actually want. And so the only thing that they can do in this case to keep the hive cool is to forage a lot of water and try to evaporate it. So in this case, they really don't want much air flowing through the hive with the outside because it's only going to heat things up. But they have to do a little bit to counteract the evaporation because they're going to have to evaporate a lot of water. And in addition, you want the least heat conduction through the outside hive surface. So this would be a representative case for India. It's one of those cases where you want the least amount of incident sunlight hitting your hive to keep your hive cooler. I'll give you one more example. This is not a good condition. This is what happens when it's super, super hot. Your bees have run out on the front because they are trying to minimize as best as possible the heat generation inside your hive because they literally cannot physically, thermodynamically cannot cool the hive as much as they need to really protect the brood. And so this is one of the reasons, it's a motivation as to why keeping the hive white, keeping it in shade, keeping it cooler is so extremely important for hives in India that are in hot regions because they literally physically cannot cool.